everyone, welcome back. My name is Maya Buria, and I'm very happy to be here to introduce today's first keynote by Laura Tripaldi, who will later be joined in conversation by Špela Petrič. Interfaces are not abstract two-dimensional surfaces. Instead, they are material regions where bodies construct complex networks of relations. Although we often think of bodies, artificial or natural, human or non-human, as endowed with essences or inherent qualities, Laura Tripaldi argues that ontologically, cognitively, and politically, the agency of bodies is a property of interfaces they themselves construct within wider material systems and across different scales. In this context, the Italian writer and independent researcher has highlighted the capability of nanotechnology to extend and transform the interface, producing non-living material systems with increasing degrees of intelligence and agency. These material systems define conventional notions of intelligence. They show the ability to adapt to their environment, detect different stimuli, and solve complex problems. One of the everyday technologies that exploit the intelligence of nanomaterials to open a technological interface between the interiority of the biological body and the political dimension of the gendered body is also the modern pregnancy test. For this reason, the author explores the historical and scientific aspects of the pregnancy test as a concrete example of the significance of interfaces in the contemporary debate around non-human agency. Laura Tripaldi is a writer and independent researcher working at the intersection of technology, philosophy, and media. In her research, she explores the ramifications of material technologies across science and culture with a post-humanist and feminist perspective. She holds a PhD in material science and nanotechnology and is the author of Parallel Minds, Discovering the Intelligence of Materials, published by Urbanomic in 2022. Špela Petrič is a new media artist based in Ljubljana and Amsterdam. She has a PhD in biology and has recently completed her postdoc research at the Smart Hybrid Forms Lab at the Free University Amsterdam. Her artistic practice combines the natural sciences, wet biomedia practices, and performance, and critically examines the limits of anthropocentrism by multi-species endeavors. And with that, I leave the floor to Laura and Špela.
Good evening, everyone. Before I begin, I would like to thank Aksioma for inviting me to this event, and also the Istituto Italiano di Cultura for making my participation possible today. So, I would like to begin by discussing the connection between two concepts. So the first concept is scale, and the other concept is surface. So the connection between these two concepts might not be intuitively understandable, but actually these two concepts are really deeply interconnected. And you can start to understand the connection between scale and surface by looking at this simple example. So if you consider a cube, and the side of this cube has a length of 1 centimeter, then the total surface of this cube is 6 centimeters squared. But then if you divide this cube into smaller parts, for example, you divide the cube into little cubes of 1 millimeter in size, then you will have a surface of 60 centimeters squared. And then if you divide the cube into 1 nanometer side cube, then you will have a total surface of 60 million centimeters squared. So this simple example shows that essentially as scale is reduced, surface is exponentially increased. And this is a geometric mathematical law that is essentially universal. It is known as the square cube law. And it might appear just as a simple mathematical curiosity, but actually it has some deep consequences in the behavior of matter. So, for example, if you take a mouse and you enlarge the mouse to the size of an elephant, the mouse will, in just a few fractions of a second, it will explode. And the mouse will explode because essentially its surface would not be enough to dissipate the heat produced by its metabolism. So this example somehow is a good way to start to understand a very important fact. And this fact is that scale is not neutral, that changing the scale of a system actually changes deeply and profoundly the behavior and the properties of the system. And a lot of these consequences are really connected to this idea of surface. And I started to deal with this concept, or with the relation between scale and surface, as I started working in the field of nanotechnology and nanomaterials. Because when you work at the nanoscale, and just for reference, 1 nanometer is 1 billionth of a meter, so it's a really, really small amount. And as I started working with nanomaterials in my PhD, I started to discover that matter really deeply changes its properties as it becomes smaller and smaller. So consider this example. What you see on the left is an ancient Roman artifact known as the Lycurgus cup. And this artifact dates back to 400 AD, and it is made of a material known as dichroic glass. So dichroic glass is composed by a glass matrix, and inside this glass matrix you have tiny particles of gold. And these particles of gold produce a very interesting optical effect. Essentially, when you shine light through the glass changes from green to ruby red. And this optical effect is related to something that happens on the surface of these particles. There is a physical effect known as surface plasmon resonance, in which essentially the electrons on the surface of these gold nanoparticles start to resonate with light, and they produce this deep red color. Of course, this deep red color that you see is really different from what we are used to when thinking about gold. If you look at the image on the right, of course, like, this is what we think when we think about gold, but it looks completely different from what you have on the left. So what is happening here? Another example that does not really deal with optical effects, but rather with mechanical properties, is spider silk. And I've been fascinated with spider silk because essentially it has, I mean, I often think of spider silk as a natural nanotechnology because essentially the structure, the microscopic structure of silk is a highly complex structure. Essentially, if you could look at the structure of silk, of spider silk up close, you would see this complex hierarchical structure that is composed of tiny nanometric elements. And the interaction between all of these elements produces a lot of incredible and unique effects. So spider silk is the strongest natural fiber that we know of. It is incredibly tough. It is able to absorb energy and dissipate energy. It also has a certain kind of memory ability in a way, because it is able to adapt its behavior depending on the environment and the stimulation it receives from the environment. And all of these properties somehow emerge from this complex nanostructure. But of course, in itself, if we just think about what spider silk is made of, spider silk is just a protein. It's not much different from what, I don't know, like the white of an egg, for example. So what you see on the right is just a solution of protein, and in terms of the composition of these two materials, they are exactly the same, but their properties are completely different. So you can start to understand that there is something interesting that happens when we start to change the scale at which we work with matter. So working at the nanoscale opens a space to investigate matter as relational rather than endowed with essential properties. What does this mean? It means that if we have to conclude that essentially the properties of matter can be so deeply transformed just by changing their scale, it means that there must be something very important that takes place not only inside of things, but at the boundary of things, at the surface of things. And in a certain way, there are some effects that emerge as objects and materials interact with one another, because on a conceptual level, the surface is the space of interaction. It is the space where bodies can come in contact with one another. So during my PhD, I encountered this concept, the concept of self-assembly or self-organization. And self-assembly is the autonomous organization of components into patterns or structures without direct human intervention. Self-assembly is a phenomenon that takes place on all kinds of scales. You can find self-assembly on the molecular scale up to the cosmic scale. So it is somehow a universal ability of material systems. What makes self-assembly so interesting in the light of what I was talking about is the fact that somehow it shows the ability of surfaces to produce new entities. For example, you can consider a virus. A virus is nothing but a conglomerate of proteins that somehow, or at least the outer shell of the virus is nothing but a conglomerate of proteins that somehow know how to organize themselves in a highly complex and functional structure. You can think about crystals that are highly geometric structures, perfect geometric structures that spontaneously form in nature. So all of these systems somehow indicate or point to the fact that material systems are able to produce a certain kind of autonomous agency, or they are somehow able to produce themselves and therefore interact with their environments in complex ways, but this complexity is always a result of the interaction of different components with each other. So as I encountered this concept of self-assembly, I started to look around and try to figure out if there was some kind of theoretical background that could help me understand what was going on and how I could try to understand this concept on a more basic level. And that is when I started to explore the whole field of new materialisms. And I came across the work of Karen Barad. And I found that well, Karen Barad somehow reflects on this idea that bodies or matter in itself is a result of a relational process. So there is like this vision that instead of focusing on the intrinsic properties of matter or what is a body, we start asking a different question, and we start asking what does a body do in relation to other bodies. And this is the process that somehow produces what we know as matter. So Karen Barad writes, matter is substance in its intraactive becoming, not a thing, but a doing, a congealing of agency. So this notion of intra-action is a concept that Karen Barad uses in contrast to the most commonly used term interaction, because interaction somehow suggests or points to the idea that it is a phenomenon that takes place between pre-existing entities. On the other hand, intra-action suggests that those entities themselves are produced as a result of a process of relation or a network of relations. And the result of this let's say, relational ontology that Karen Barad puts forward is a reflection on what we mean by agency. And agency is a really complex concept, and as a scientist, it's maybe a concept that is bigger than what I can actually deal with. But in my understanding, agency is the ability of bodies or material systems to define themselves as a self. So when I deal with self-assembling systems, the question for me is, what is the self that is being assembled, and how is this self produced? So in a way, in the light of this productive power of surfaces, especially when we deal with the nanoscale and when we extend the ability of surface to have an effect on the properties of bodies, I started reflecting on the fact that maybe the concept of surface in itself is possibly limited or limiting. This is because what we mean by surfaces, I think might be illustrated by the diagram that you see on the left. And I really like this diagram because it captures what we imagine when we say surface. So the diagram on the left, you can see the blue dots and the orange dots. So these two are essentially two materials or two different phases of matter. And in the picture on the left, you can see that these two phases of matter, as they come into contact, they are essentially separated by a rigid line. And this rigid line is essentially an abstract construct. On the left of the diagram, you can see an alternative paradigm to this idea. And this is what, in chemistry and material science, we call an interface. So differently from surfaces, interfaces are not abstract lines that separate things, but they are actually material spaces. And in these material spaces, there is a production of a new kind of identity or a new hybrid state of matter. And you can see that in that picture, we have a mixing of the blue and the orange that produces a new different phase of matter. And often, this new different phase of matter cannot really be reduced to the individual properties of the components that you started with. And you can see some of these effects even in everyday materials and in everyday objects. So one example that is really intuitive, but I think very effective, is simply a droplet of water. So water, we think of water, and I mean, we have heard a bit about water earlier, and I was really interested in that because I agree that we tend to think of water as just like this universal substance that just never changes, it's always the same. But actually, even in physics and in chemistry, water changes its properties depending on the environment in which it finds itself in. So if you deposit a droplet of water on a slide made of glass, the droplet of water will become almost completely flat. If you deposit the same droplet of water on a plastic surface or a Teflon pan, then the droplet of water will be spherical. And this simple example can show you how the intrinsic properties of bodies can really change depending on the interface these bodies produce in contact with other materials. Another example is opal. So opal is essentially a mineral that is made up of tiny spheres of silicon dioxide, which is essentially glass. And as you all know, glass is colorless. However, if you have spheres of glass that are small enough, like a few hundreds of nanometers, and you arrange them in an ordered pattern, then these spheres of glass can start to interact with light in a very particular way, and they start to produce optical effects. This is an effect that in physics we know as structural color. And so a colorless material in its interface with light starts to produce a whole range of different colors. So interfaces They are, of course, the interface is, of course, a scientific concept that comes from chemistry. But I started to wonder what is the significance of interfaces even outside of this strictly scientific field. Is there a power to the concept of interface that we can then apply even outside of science, even outside of chemistry? So the interface just starts as the answer to a physicochemical question. It starts as an answer to a question about why do we observe certain things? Why do opals appear colored instead of colorless? Or why are spider webs so strong? And then we come to this concept, but this concept has the power to be applied even outside of strictly scientific fields. So one field in which I believe the concept of interface might be powerful is epistemology. So epistemology answers the question, how do we know what we know? And in knowing what we know, we encounter interfaces always. If we have to know what we look like, we have to look in a mirror. And the mirror is an interface that allows us to access this knowledge about ourselves. If we have to know something about a bacterium, we need a microscope to look at it and to understand its behavior. So in epistemology, interfaces are those material constructs that allow us to produce this knowledge. And in a certain way, epistemology somehow shifts and moves into ontology very easily. If we start to consider that there is no way we can know anything without an interface that allows us to have this knowledge, and maybe our own identities are produced as a result of the encounter with an interface. So in a certain way, interfaces can help us also answer the question, not only how do we know things, but also what are things. And this is the insight that Karen Barad brought to the table when she started discussing, for example, quantum mechanics and the complementarity principle in quantum mechanics, and the way in which what we know about particles or quantum particles is only produced as a result of the interaction with measuring apparatus. And this is a similar idea. But then ontology somehow, to go back to the real world in a way, or to the more contingent problems, somehow leads to the social and political question, because once we start to make statements about the identities of things and the identities of ourselves and the identities of bodies, those statements are necessarily political statements. As Foucault teaches us, knowledge is always knowledge power. Every time we say something or we make a statement or we say a truth about a body, we locate that body inside a wider political network. So in order to illuminate or elucidate all of these complex aspects of what an interface is, I started looking at technologies that have been associated with gender identities. And especially, I started looking at the pregnancy test. So the pregnancy test is a technology that most of us know very well. And it is one of the most commonly used and known applications of nanotechnology, even though often maybe we don't think about it that way. But the way a pregnancy test works is by using actually gold nanoparticles, the same kind of material that we saw at the beginning of the presentation in the dichroic glass. That is the same material that gives this red line that will tell you whether you are pregnant or not. It is a scalar technology because it creates a connection from the molecular scale, so the possibility of detecting a hormone molecule, to the personal scale, so what is the impact of this knowledge in my life, to the social scale, so what is the political effect of making this knowledge accessible to women, to people. And so the pregnancy test is a technology that constructs our political identities as well. So the pregnancy test is a very interesting technology, and unfortunately, I don't believe I have time to tell you a lot in detail about the history of the pregnancy test. But what I would like to take away from the history of the pregnancy test is the fact that often interfaces bring together a lot of non-human agents. And often what we know about ourselves and what we know about what it means to be human is the result of the participation of a lot of non-human subjects. For example, the earliest pregnancy tests that we know of date back to ancient Egypt, and they were based on a practice of essentially urinating on some barley seeds. And if these seeds would germinate, then the woman would know that she was pregnant. Actually, this practice really seems like kind of a magical thing, but it has some scientific foundation. And then from these earlier practices, other pregnancy tests that exploited organisms, non-human organisms, have emerged. So in the 1950s, for example, it was common practice to use a specific species of frog, Xenopus levis, as an interface for the pregnancy test. And scientists would inject the frog with human urine, and then if the frog produced eggs, then it meant that the test was positive. So this is a really weird and not well-known history of this technology, but really goes to show the deeply non-human nature of this knowledge that we always consider to be so human. Then, as technology progressed, we moved on to molecular technologies that allowed us to detect essentially the presence of a certain hormone by observing the agglomeration of blood cells in a test tube, essentially. And then with the age of nanotechnology, we landed to the pregnancy test as we know it today. But even these more advanced technologies still carry within themselves the memory of this non-human origin. All of these technologies are made by, for instance, producing antibodies, and these antibodies are produced from the blood of rabbits. So in a way, we still have this connection with the non-human background of this knowledge. So what is then the political action? What is the practice or the praxis that we can take away from all of this? And of course, this is not an easy question to answer, but I believe that by looking at the history of the pregnancy test, we might get a hint on what is the political power of interfaces. So in the 1960s, a designer known as Margaret Crane started working on a prototype for the first home pregnancy test. And the idea that women themselves would be able to let's say, practice this laboratory procedure in the safety of their own homes and to have like this private knowledge of their own bodies was actually revolutionary. And it was also perceived as a challenge to to medical institutions, to, let's say, institutional science and the institutional circuits of knowledge production. So it was a long process before the pregnancy test, the first home pregnancy test, was actually made available on the market. But its existence has changed what it means to be a woman today. So in a way, there is a space where I believe we should start looking at interfaces as spaces that can be politically reappropriated. So technology as a non-neutral participant in our lives and in the construction of our identities really should be considered as a space that can be politically reappropriated to redistribute or, let's say, gain control of the knowledge that is being produced on our own bodies. So I would like to conclude and leave you with this quote by Judith Butler. So this is my favorite quote by Judith Butler in Gender Trouble. How does a body figure on its surface the very invisibility of its hidden depth? So I believe that the discussion of interfaces and their political significance somehow points to the idea that this surface or this superficial space of our identities and of our bodies is actually what carries the most meaning, or at least is a space that can be actively transformed in political action. So of course, here Butler is talking about her idea of what performativity is. So performativity in the context of gender means that instead of locating identity in the most inner, essential part of ourselves, we are able to locate identity on the surface of our bodies and in the relations that we form between each other on a social and political level. What I believe as, let's say, new materialists we can do to work on this concept that Judith Butler left us is the idea of adding a material depth to this concept of performativity and trying to understand surfaces not only as spaces of the production of discursive identities, but also as spaces of material action. And technology is, let's say, the way that we can try to, I mean, it is not an easy way, but it is probably the only way that we have to really transform our identities through the interfaces we construct with the world. Thank you.
Thank you. Hello. Thank you so much, Laura. This was really great. I would like to start our conversation by drawing from, I think, one of our common experiences, because my background is also in science, and about 10 years ago I left that realm. And I'd like to share, I don't know if you're familiar with Isabel Stenger's Another Science is Possible. Mm-hmm. Yeah, so she has this really wonderful description, or like a parable of a scientist, comparing them to a sleepwalker. And they're walking back and forth on the edge of a ridge with full confidence, without falling off. And they can do this forever. That is, until someone wakes them up, right? And at that point, they lose balance and they can no longer do science. And what this actually refers to is the fact that in today's modern, contemporary, or as Stenger says, fast science, the scientist is not really allowed to consider their investigations within the wider cultural context. Because once that happens, they can not really perform the same type of science. So in this way, they sort of put a divide between them and political, societal, social interests, all this stuff, right? And what I think you are doing here as a scientist that has been trained in this hardcore material sciences, you're bringing the societal context to nanotechnology. So I would like to hear a little bit more about how it was for you to wake up, if I could use this metaphor.
Yeah, yeah. Thank you for this question. Actually, I mean, it's great to be in conversation with you because of our shared background and how, like, you also managed, like, to move on from a strictly scientific background into something else. And yeah, I mean, it's not. it's not easy on a personal level, because like you start to question a lot of what you've been doing for a long time. But in a way, yeah, I think like this like hyper specialization of science today, of course, is difficult when you are inside it, because you are really encouraged, like, by a lot of, I mean, by a specific academic system to really focus on just a hyper-specialized field and nothing else, and you have no time and no energy left to look around, even, I mean, around your own department, and so, like, you really have, like, this tunnel vision. Somehow, I am still fascinated by this process. Like, I see like how this is destructive in a way, but I also see how, I mean, I am fascinated by, and this is why, I mean, somehow, even though it was difficult, I still enjoyed my process of working as a scientist, because somehow there is a lack of control. I mean, specifically because the scientist is kind of sleepwalking. It is a bit scary to think that, like, the future of, or the progress of humanity is in the hands of people that don't really know what they're doing, and it is terrifying. But in a way, it is also kind of fascinating because there is an element of, like, losing human control on scientific processes, and this is kind of a double-edged sword. But, like, in a way, I see, like, maybe also the poetic aspect of it, or in a way, maybe I tend to think, I don't know, like, maybe, you know, all of these non-human elements can kind of take over or change what we think of as science, you know, the scientist that investigates nature. Like, this model is becoming obsolete because no one can control the process of knowledge production anymore, not one person. I mean, it's like also delocalized and all over the place, and so, like, yeah, it's interesting to see what's coming out of this.
Yeah, I would wonder actually what your opinion on how to perhaps empower the scientists might be, but I think we're going to come back to that in a bit. So, the next question I have concerns the question of scale. It's very obvious, right? We do not have immediate access through our perceptual apparatus to this nanoscale. So all the information, all the theories, all the models of this phenomena that happens at that scale are actually inferred, right? So they're sort of representations of mostly data, and this data isn't necessarily even collected by the single person, right? It's a very, very distributed and convoluted way of coming close to some sort of facts. So it's, you know, even further than just looking through a microscope. So the best that you can do is actually understand the phenomenon and judge it from what it looks like from here, you know, using this apparatus under these conditions. And in a way, on the example of climate change, this has come to sort of undermine even the validity of the concept of global warming, etc., right? Because it's such a distributed process that taps into this vast machine of observation. The data comes from, you know, is spread out in time and space, right? And so, in a way, that is not just something that the public needs to accept and trust science. It is also embedded in the everyday practice of the researchers themselves. It's the question of how to navigate this space that is actually virtual, imagined. It's felt maybe, And so Natasha Myers writes this book called Rendering Life Molecular, and it's an ethnographic research, and she follows crystallographers, from students to professors, and sort of describes how the different techniques that the scientists use to envision the three-dimensional structures of proteins, which they will never see. Have never seen, right? And so there's sort of like a joke that by the end of this crystallization course, every student has at least once dreamt of crystallization. So in a way, while these scales are not accessible and while we have to trust the data, in the day-to-day practice, the scientists as people use all the capacities they have as people to try to navigate this imaginary space. And I would be interested, from your personal experience, what kind of heuristic tools and models, similar, you used, and then contrasting that to sort of like the practicalities, the day-to-day, the cooking, or the, sort of lab work.
Yeah, so like this is a really interesting question, because in a way, I mean, not only nanotechnology, but like most science today like deals with things we cannot represent or see, both because they are too small or too large. So we are really always missing out. But somehow we tend to, I don't know, I mean, I think there is like a tendency to think about the history of science as a history of optics sometimes. And I mean, I like that today, like there has been a lot of discussion about optics, because it's a super fascinating topic. So for example, like we think of progress like as the the ability to, for example, to see increasingly small things. So like from the optical microscope to the electron microscope and beyond. And this is like somehow a partial view of the history of science or the development of science, because there are sciences that have worked with invisible things for a very long time, and this was never a problem. And I am thinking especially of chemistry. So I come from a chemistry background, so I carry like this chemical background also in my work on materials. And like, for me, I mean, I often think about the fact that like chemistry was like a flourishing science well before like we even knew that atoms and molecules existed. Like this was not even a question. It was not a problem. And like chemists did represent compounds, not maybe in the way that we think of today, but I have a feeling that in these early days of chemistry, there was not the expectation that these representations were like optical models of things. They were just starting points, or maybe artistic or symbolic representations of something that was always beyond representation, but that did not matter, or it did not prevent scientific work. So this is something that like I have experienced myself in my work in the laboratory. I mean, I was always like doing synthesis, essentially. Like I was an inorganic chemist first, and then a nanotechnologist, and then I developed nanomaterials that I actually could not see. But like synthesis is like the practice of making a new molecule or a new compound or a new material from scratch. Is a very fascinating process, because you have a kind of dialogue with the matter you are interacting with, you know, and like you don't have to know exactly what is going on. You don't have to control where each atom or molecule goes, because matter somehow knows what to do it does its own thing, and then you understand what is happening, or you try to understand what is happening, and then you change the conditions, and then matter responds in a certain way. So there is like this back and forth. So in my experience, I mean, of course, I had access to like electron microscopes and whatever, but like often that was only the end of the process, because even before I went to the electron microscope, I already had a feeling of what was going on, and like the whole process happened before. Like catching the picture was just like, okay, we need a photo for the publication, you know? But like it was really not the whole point. And I mean, I think like there is something there, like in this idea of synthesis that I really care about. And I mean, maybe I still need to think about it a bit, but yeah.
So would you say that it comes from an intuitive place? Is it at all, do you at all feel it?
Yeah, I mean, there is often like this idea that like chemists have like this kind of magical intuition. I'm not sure if that's true, I mean, but there is like some kind of pre-modern relationship with matter that still carries on in chemical laboratories, I believe. Like chemists, by nature, often don't know what to expect. And they like accept that maybe today the compound will not do what I expect it to do because I don't know. Or that, I don't know, like I get a feeling that something is wrong with this, but I don't even know rationally what exactly is wrong, you know? And like maybe this is a bit, I don't know, romantic view of the chemical practice, but I actually believe, like from my experience, that it is there somehow. And I mean, it's not, what I would like to underline is that it's like a relationship of the scientist with the material. So the material is not just a passive object of study, but somehow responds and enters into a dialogue.
Yeah, I actually shared a similar experience on this level as well. And what I kind of found is that it is hard to explain and share, most of all. So this is also, it kind of leads into the next question that is about ontology and the implications of the relational ontology that you described. Because you emphasize that, well, in your book as well, Parallel Minds, that nanotechnology isn't only about this top-down manipulation and not about moving single atoms around at all. That it's really important that self-assembly happens, and even recently these sort of dynamic nanomolecular structures that are dissipative, that are not permanent, that require energy to maintain themselves, are being developed. And of course, this brings forth also the agency of the material itself that you mentioned. And this notion of blurred boundary and also the hybrid interface and the blurred boundary between living and non-living, it really reminds me of this insight that we had when the human turned out to be only a holobionts, right? For example, with the microbiota in the guts, etc., right? So our autonomy as humans was now being put into question through the interaction with this non-human agency, albeit it was a living one. So the thing that I'm getting at is, on one hand, this insight for a scientist can be quite overwhelming and perspective changing. However, as you also say, culture cannot be separated from the material it makes, and the material practices sort of define it. And most of the funding of nanotechnology comes at this moment from military, from industry, right, from nation states, etc. So the question that I have is, if nanotechnology has this potential by understanding that it's ontologically maybe opposite of what we would otherwise employ in this environment of control, right? How do we make that actually happen when it depends on so much more than the phenomenon itself? Or in other words, to rephrase it, how would we make more feminist nanotechnology, and who needs to have the know-how or this capacity to navigate the invisible space and the abstract structures? If you could share some thoughts.
Yeah, so I totally agree with you, like the fact that a technology is based, for example, on like the localized models, or it's like based on self-organization or whatever, like this does not mean that then the technology is emancipatory in itself. And I mean, I think we can see this on many levels, like in the history of technology. I mean, like, I guess, like, at first we thought AI was going to be, like, this emancipatory technology, and then here we are, so. And this is the same with material technologies, I guess. Like, I really agree with you. So, I mean, maybe, like, an answer to your question, yeah, really is, like, the reason why I was speaking about the pregnancy test. Is the fact, I mean, I have to say, like, first of all, that, like, moving from Parallel Minds, my work with my first book, to my recent research for my upcoming book, like, my optimism about technology, like, kind of collapsed. Maybe this was, like, because of, like, also, like, historical and personal reasons. So, I mean, it is like I am conflicted about this. Like, I am evolving in this view. But, like, the pregnancy test, out of all of the technologies that I have explored recently, is one of those that, like, leaves me with a bit of hope. And this is because it shows that some technologies have the power to bring, I mean, that technology, let's say, is a space that can be politically appropriated in a certain way. I mean, I feel like a lot of the oppressive power of technology in general, like, comes from the let's say, the fact that the material networks that produce those technologies remain hidden. So, like, and I think we have seen this, like, today, like, with the previous panel, like, it is really fascinating to see how somehow, like, the oppressive powers of technology, like, they thrive on our unknowing of the networks on which those technologies are based. So the starting point is, like, bringing those networks into light, bringing the materiality of these interfaces into view, and, like, the complexity of these interfaces, right? And for the pregnancy test, I believe it's kind of similar. So it is different if we somehow, if science and technologies are just a black box that, like, spits out truths about who we are, then this is, like, clearly oppressive. Like, we have to submit to this, like, knowledge that is cast over us. But then if we can open the black box and understand, like, what's inside and how it is composed, and, like, all of those also non-human elements that make up a technology, and then we start to kind of try to reappropriate and occupy that space as a space of transformation of who we are actively, then it becomes something else. And this is why, like, the pregnancy test at first was, the self-pregnancy test at first was seen as, like, really dangerous, like, from many sides, like, politically, from the medical establishment, because, like, there was, like, somehow this belief that women could not have this knowledge. It was dangerous. Like, what if then, like, you know, there would be a rise in the illegal abortions, or what if women, like, kill themselves if they realize they're pregnant? Like, there was all of this, like, panic, because, and also there was a belief that women were not able to produce this knowledge. Like, they are just not capable of handling, like, the apparatus. And, like, challenging this belief and like showing how easy it is to deal with technology, and like also showing how like technologies actively participate, like they're not like passive instruments, but like they themselves get emancipated like from the institutions that produce them. Like, so I believe like this is kind of at least a partial answer.
So DIY nano hack labs, yes or no?
Yeah, I mean, I would love to, so looking forward.
I'm wondering, is there a question from the audience? Laura, yes.
Is it? Okay. Thanks so much. Can you tell us a little bit more about the upcoming book that you're working on?
Yeah, of course. Yeah, thanks for asking. So my, actually, yeah, I started from hard science. I started getting interested more and more in gender studies and how like science and epistemology interact with our gendered identities. So my upcoming book will be kind of a reflection on the histories of various technologies associated with gender. And the pregnancy test is one of those technologies that I will be dealing with, and their histories, and in a way, like trying to focus in a way on the ambivalence of those technologies. Like, of course, as we were discussing earlier, like they have some kind of emancipatory power, but then on the other hand, like there is always like a very deep oppressive shadow of all of those gendered technologies. And then like on a more theoretical level, I would say like trying to understand the technology as the space where identity is produced, and also gender identity is produced and also potentially transformed. Yeah. So, thanks for asking.
Is there one more short question from the audience?
Hey, what kind of material action, both on epistemological as well as political level, is needed to counter the theory of artificiality of intelligence being imposed upon the practice of natural intelligence? While AI is still largely theoretical, it already seems as if it's making the unfathomable neural nanomagic of the brain appear obsolete. Or in other words, how does the difference between the two black boxes of mind versus neural network look from the epistemology of nano-savvy material intelligence?
Yeah. Wow, this is a very interesting question. So I tend to look at artificial intelligence like as a more general term, like because a lot of my research earlier was like dealing with smart materials, soft robotics, and so like all of this new field of like intelligent materials, let's say. I have always focused, like also because of my background, on like the material aspects of intelligence and like artificial intelligence also from a different perspective. Like, what is an artificial intelligence? Is it just like the algorithmic software side of it, or is it like something else? And what is like the potential implications of like also changing the hardware on which we run these intelligences? Okay, so in a way, I mean, I am not an expert in AI in the conventional sense, so my answer can only be kind of generic, but somehow I feel like, I mean, there is a focus on AI as being like this disembodied power, but like, and there is like also a lot of like interest, for example, in like this new like embodied computation, but like in a way, I mean, yeah, computation and like AI are already embodied we just like forget, because it is often like convenient to forget about those bodies and their material existence. And I feel like yeah, earlier today, like the discussion on semiconductors and like the political implications of extractivism of semiconductors somehow remind us of like the fact that like AI has a body. And it's just a body that we're not really ready to deal with. And it is already a body that like interacts with our own body. So yeah, I don't know. I mean, I'm not sure if this is answering the question, but like in a way, if this is a question about the embodiment of AI, then like I feel like we need to kind of also shift the view, like not only on the more technical side, but also like on the wider meaning of what it means for a technology to be embodied or embedded within, yeah, our world.
Yeah, absolutely. Thank you very much, Laura Tripaldi.
Thank you.
Thank you, audience.
Thank you, Laura. Thank you, Špela. And now we have the second break, after which we continue with the keynote, Decolonizing Machine Vision, Algorithmic Anxieties and Epistemic Violence, by academic, author, and editor Anthony Doney, followed by the conversation with writer, philosopher, and critic Mojca Kumerdej. We will start at 7:30 p.m. sharp, p.m., not a.m., not tomorrow morning, but now. As part of the audience is following remotely, and we don't want them to wait in front of the screen, I really kindly ask you to be back in the venue in time, actually better 5 minutes earlier than in time. Thank you very much.